so we're going to review factoring here real quick at the beginning. So if you want to factor, I would tell you, you want to set this equal to 0. So if you want to factor, set it equal to 0. So I'm going to start out and I'm just going to move the 40 to the other side real quick. So my problem's really x squared minus 18x minus 40 is equal to 0. Okay, now we're going to multiply a times c and add to b to do any kind of factoring. The nice thing here, your a value is just 1. So it's 1 times negative 40, so that would be negative 40, and I want to add up to get negative 18. Now, I'm going to go ahead and just start each of my factors with an x, because if I do x times x, like if I FOIL that, that will give me x squared, which is what we have. And I just got to fill that in with the two numbers that fit those two requirements. So now, 40 has a lot of options. You got 1 and 40, you got 2 and 20, you got 4 and 10, and you've got 5 and 8. So I somehow have to get a combination. If I multiply them, it would be negative 40. So to get a negative, you got to have one negative number, one positive. And then I want to add up to get negative 18. What combination of factors can I use there to make both of those things happen? The 2 and the 20. Okay, which one's negative, which one's positive? If you do negative 20 times positive 2, that's negative 40. Negative 20 plus 2, that's negative 18. So what we do in the factors, doesn't matter which one comes first or second, just put one of them as a minus 20 and one of them as a plus 2. Like if we multiplied that back out, it's just going to give me exactly what I have above. But if we have the factored form, you can tell me the answers real quick, because it's just what would you plug in for x to make that little set of parentheses 0. So if I had x minus 20, what would you plug in for x to make that 0? Plus 20. Okay, if I had x plus 2, what would you plug in for x to make that 0? Negative 2. Those are your two answers. Done with the question. That's it. Okay, so that's factoring. Okay, now I'm going to solve the same problem, but we're going to do the completing the square that we did a couple days ago. Okay, now, completing the square, you actually want it kind of set up the way they set it up in the question. You want the x squared and the term with the x on the same side and any plain numbers on the other side, because we're going to complete the square. So what I'm going to do here, I'm going to write x squared minus 18x plus, we'll just leave a little blank here. On the other side, I'm going to keep that 40, and I'm going to add that little blank to the other side, because we're going to add something to complete the square on the left, and I got to keep my equation balanced. So whatever I do there, I got to do it to both sides of the equation. Okie dokie. Now, to complete the square, you're going to take your b value, which is just going to be negative 18. You're going to divide it by 2 and square it. That's the little formula to find the number to get you the perfect square trinomial. On the left, that gives you the thing that's going to factor to be exactly the same thing. All right, so for this guy, I'm going to try and squeeze it up here. I would do negative 18 divided by 2 squared, which would just be negative 9 squared. Which, what would I get if I squared negative 9? 81. Did you just say 3? You're thinking the square root. Okay, we're going to do 81. Okay, so I'm going to add it to this side. I'm going to do the same thing, and I have to add it to the other side to keep my lovely equation balanced. Now, on the left, this is a situation where the two factors would be exactly the same. Multiply to get 81, add to get negative 18 if you're having trouble. As long as you did this correctly, whatever's in the factor with the x should match what you squared. So if I do negative 9 times negative 9, that's 81. Negative 9 plus negative 9, that is negative 18. So the factored form here, this would be x minus 9. If you want to skip this step, you can. Two factors would be exactly the same, but the whole point of doing that is so you can squish it together and square it. On the other side, you literally just add the 40 and the 81. That's going to give you 121. And the reason we want the two factors to be the same, so we can squish them together like that, is then I can cancel out the squared by taking the square root. And then what we'd have left, you'd have x minus 9. Anybody know square root of 121? 11. Okay, so don't forget the plus and minus because we introduced the square root there. Now, I got to move the 9 to the other side. So I would have 9 plus or minus 11. Now, if you don't see an I, which I don't, If you don't see a radical, which I don't, you can simplify that. So we can actually add these together. So if I do 9 plus 11, that's 20. And if I do 9 minus 11, that's negative 2. And then hopefully you guys see those are the exact same two answers I got when I did the factoring, right? We had 20 and negative 2, 20 and negative 2. Just a different method for solving, but we're just practicing using these methods. So you can use these methods on different quadratics. Okay, now the last one we're going to do, we're going to review what we did yesterday, which is quadratic formula. And let me just write it real quick on the screen so you guys can see this. It's negative b, or opposite of b, plus or minus square root b squared minus 4ac all over 2a. Now, if you are doing the quadratic formula, this is like factoring where you would want to set this equal to 0. So we were practicing that a bunch yesterday. So this is x squared minus 18x minus 40 equals 0. If all the terms had something in common, then maybe we could reduce, but we don't here. So I'm just going to go ahead and write my a, b, and c values. A is 1, b is negative 18, c is negative 40, and we're just going to plug it into that lovely quadratic formula. All right, so opposite of b would actually be positive 18, plus or minus square root negative 18 squared minus 4 times 1 times negative 40. Sorry, I'm kind of bleeding into this question over here. Everybody over 2a, which would be 2 times 1. Now, I kind of do this in 2 steps just to help me figure out whatever's under the square root. So I'm not typing a square root. I'm just going to copy what I have under the square root here into my calculator to figure out what that is so we can see if we need to break that radical down. So I can do negative 18 squared, 4 times 1 times negative 40, and I get 484. Now, I don't know if you guys know this off the top of your head, but 484 is a perfect square. So I can actually just take, if you want to try and break down a factor tree, everything will cancel out. But I just happen to know that's a perfect square, so I'm just showing you that that's the square root. So what we have here, this would be 18 plus or minus 22 over 2. You don't see any radical, you don't see any I, so we can simplify this. If I do 18 plus 22 divided by 2, that's going to give me 40 divided by 2, which is 20. And if I do 18 minus 22 divided by 2, that's going to give me negative 4 divided by 2, which is negative 2. And then you can see all three of these different methods gave me the same answers. So if I wanted to use the quadratic formula, I got 20 and negative 2. If I wanted to complete the square like we did up here, 20, negative 2. If I could figure out the factors, I would probably, in that case, tell you that's probably the fastest method of the three. If you can factor it. But if you can't factor it, these other two are definitely options. Is anybody having a question about any of the methods? Okay, now I'm going to give you guys another one. So these two problems are the same. So again, we're just practicing the two methods. This is a situation where the quadratic is not factorable. Okay, so you can't always use factoring because I might not be able to find two things that multiply to get something, add to get something else. So I'm going to set this equal to 0 by adding 2 real quick. But if I tried to factor that, like you're not going to tell me two numbers that multiply to get you 2 and add to get you 10. It doesn't exist. So you can't always use factoring. You can always use quadratic formula and you can always use completing the square. So on this guy, just a little review from yesterday. A value is 1, B value is 10, C value is 2. So opposite of B would be negative 10 plus or minus square root. B squared is 10 squared minus 4 times my lovely A value, which is 1, times my C value, which is 2. Everybody over 2 times A, so just 2 times 1. All right, so I got negative 10. Just grab the calculator real quick. All right, we're going to do 10 squared minus 4 times 1 times 2. And I'm going to get 92. All over 2a, so 2 times 1 is just going to be 2. Okay, 92 is not a perfect square, so we're going to have to see if we can't break that down. So I'm going to see if I can steal a little bit of space here. I don't know off the top of my head. I know that's an even number. So I got 2 and 46. And then 46 is 2 and 23. And 23 doesn't break down. That's a prime number. So this is a really short factor tree. You do have, though, a pair of 2's, and then we have a 23. All right, so here's what I'm going to do. I'm going to rewrite that square root of 92 plus or minus 2 comes outside, and then that 23 would stay underneath. Everybody over 2. And just to show you that that's right, I'm going to grab my calculator. So if I do square root of 92, garbage decimal, 2 roots of 23, same garbage decimal, so I know that we simplified that correctly. And then I'm going to do one more thing. And you can't always do this, but I'm trying to practice this with you. If all 3 of these do not touch the radical, all 3 of those are divisible by 2. So I'm reducing this. That's legal. If any one of those is not, then you just stop where you're at, but we can go farther here. So negative 10 divided by 2 would be negative 5. Plus or minus 2 divided by 2, you would just see a 1 there. And so we would just have square root of 23. So this one's a little bit more complicated than the one we just did, obviously, because we had nice numbers on that last question where we practiced all the different methods. This one's not as nice. So let me show you the completing the square here. All right, so completing the square, same question. I'm just going to leave a little space. I'm going to write x squared plus 10x, leave myself space to complete the square. This is going to look different, but I'm going to show you we can get the same answer if you like this method better. You go ahead, leave the negative 2 on the other side. You don't want it set equal to 0 when you're completing the square. You want your squared term and your term with your x on the same side, which I have there. And to fill in that little blank, you're going to grab the b value, divide it by 2, and square it. So for this question, it would just be 10 divided by 2 squared, which is going to be 5 squared, which would give me what? 25. Okay, so 25, whatever you do to one side, you have to do to the other side. So we're going to add 25 to both sides. Okay, now, factors of 25 that add up to 10. So multiply to get you 25, add to get you 10. This is, skip this step if you understand this, x plus 5 times x plus 5, or the whole purpose of doing this, x plus 5 squared. Now, the other side, you literally just do negative 2 plus 25, so that's 23. And then we got to do 2 steps to solve this. I'm going to take a square root, and so I'd have x plus 5 plus or minus, since we introduced the square root of 23. And then I'm just going to move the 5 real quick to get x alone, so I'm going to subtract that. And then you guys are going to see right here and now, isn't that identical to what we just had? It's just a different way to do it. In that case, for me personally, I'd probably argue completing squares maybe a little bit faster because I don't have to simplify the radical or anything like that. But it just kind of depends on the question, what you're more comfortable with. So if you want to try to complete the square, if you like the quadratic formula, you can use either one. But you get the same answer. Is anybody having a question? Okay, we're going to do a little application of our lovely quadratic formula on the back. And I'm going to use that little vertical motion formula that we've been looking at in the last couple of units. Okay, so this says a rocket is launched from a 98-foot cliff with initial velocity 144 feet per second. And we've seen this formula a couple of times, but let me, I'm just going to kind of sketch a picture. So this is not being launched from the ground. So it says they're 98-foot cliff somewhere up in the air. So I'm just going to kind of come up here. We're going to launch this rocket, and eventually the gravitational force will pull it back down to the ground. But this is not kind of similar to a lot of the questions we've practiced before. A lot of those we've launched it from the ground or whatever. So this is going to go from 98 feet. So it would look something like that. So we're not going to use any symmetry here. We're just going to use algebra to solve this. but I'm going to go ahead and plug this into the formula. So if you guys remember, the height of the object is like where we usually see the y. Negative 16 is gravity. The letter t is for time here. It's usually where you guys see the x. What we got to replace is the velocity. So we're going to put in 144t. And the c value is your initial height. So since we launched the rocket from a 98-foot cliff, I'm going to go ahead and put plus 98 there on the end. Okay, now this is a little bit of a review question. So find the time it takes the rocket to reach its maximum height. This is just, on my little picture, going to represent the vertex. So time would go across the bottom and height would be across the y-axis. So any point that I find, the time is the x-coordinate of the vertex. The maximum height is going to be the y-coordinate of the vertex. This is your little negative b over 2a, which you guys have seen a bunch in the quadratic formula that we've been working on. So this would be negative 144. Now just do me a favor, on the bottom either put parentheses or figure out what this number is before you do the division. So the bottom of the fraction 2a would be 2 times negative 16 here. If you want to do this in the calculator, you totally can. Just put parentheses around the bottom. Or if you want, that should just be negative 32 if you multiply those guys together. The negatives are going to cancel out, and this would be 4.5. So a little review right here. This would be 4.5 seconds. That's how long it would take. Now the actual height, all you're going to do is plug in, so I would grab my calculator, 4.5 for the time, because you know that's the time. We're going to try and figure out the height. So we're doing negative 16 times 4.5 squared, don't forget to square it, plus 144 times 4.5, and then plus the 98. So I'm just plugging this into my calculator. So I know the time, 4.5 seconds, so I just replace a t everywhere I see a t for time in that lovely formula. And this will give us our height. So the maximum height, I got 422. This would be in feet. So that would be this. This is definitely not drawn to scale as I'm looking at it, but this would be 4.5 and 422 here. Now, this little review. This one says, at what time does the rocket, and pretend I did a better job drawing that because this is not to scale. At what time or times does the rocket hit 343 feet? Okay, so this is radically not to scale or anything, but like let's just say this is 343, right? We know it gets up to a height of 422. So I should have 2 places on that graph where that would hit 343. So it's going to hit it, we're going to hit 343 on the way up, but then we would also hit that same height on the way back down. We're going to grab our calculator to calculate this today, but we're just going to use the quadratic formula. So it's saying at what time is the height that? You're going to plug this in for the height. So when is the height 343? So plug in 343 for the height. And I'm just copying the formula. And these are kind of big numbers, but we're just going to use the calculator to do this. The first thing you have to do to solve this lovely equation, we're not going to try to factor, we're not going to complete the square. We're going to set this equal to 0. And to do that, I just need to move the 343 to the other side. Everything else we are doing on the calculator. Now, I'm taking, let me see, this will be negative, so I'm going to do 198 minus 343. So that term on the end there's negative 245. Okay, now you saw my picture. I should have 2 answers to this question, right? Because I'm going to hit it on the way up and the way down. So we're just going to plug this in, quadratic formula. I'm going to do, my A value is negative 16, B is 144, C is negative 245. Now, if you're doing a word problem like this, I'm just going to break down the quadratic formula a little bit. You don't have to worry about leaving this in simplest radical form or anything like that. It's going to tell you to round to like the nearest hundredth on the questions that we're going to practice. So I'm going to do negative 144 plus or minus square root This will be a huge number. 144 squared minus 4 times negative 16 times negative 245. All over 2 times negative 16. Now, I would recommend do like at least one step like we were doing yesterday. You do not have to break down whatever is under this radical because it's going to be a huge number, but maybe get it down to one number so we lessen the amount of times we can make a mistake here. So we're doing 144 squared minus 4 times our A value was negative 16 times our C value was negative 245. All right, and it's a huge number, so you do not have to break this down. We're just going to round to the nearest hundredth. Okay, now my 2a on the bottom, 2 times negative 16, is negative 32. Both of these answers are going to be positive, okay? So just on my calculator, I'm going to do negative 144 plus square root 5056, hit equals, sorry I'm not on the screen, hit equals after you do that, and then divide that by negative 32. We're just going to do the approximate solution here. So this is, on the way up, I did the adding first. Let's say like 2.28 seconds. 2.28 seconds. Because that's going to make a little bit more sense than leaving that in radical form for the situation. Let me pull this back down. See if that makes sense to you. So some here on the way up at about 2.28 seconds, I'm going to hit the 343. Now we're going to hit that on the way back down too, so that's going to be where I get my other answer. So again, I'm just typing this into the calculator. Do negative 144. This time I'm going to do minus, because we had plus or minus. I did the plus first. So now do the minus square root 5056, hit equals, and then divide it by that negative 32. The negatives are going to cancel out here. So this is about 6.272 seconds is where it's going to hit as it goes back down. So 2 answers to that question. And then I got one more. This will be really similar. We're just going to use the calculator to do this. Okay, let me pull my graph back up so you can see it. The last question is going to ask you when you hit the ground. So that's going to be here on the way back down. If you actually solve this, and don't maybe draw this on your paper, but one of the answers, if I do the quadratic formula, because we launched it off a 98-foot cliff, one of the answers from my quadratic formula is actually going to give me a negative number, which would correspond kind of to this point on the graph. I don't want that point. I want to know when it comes back to the ground. So I know it's got to be a positive time that it takes to get here. So we're going to set this up. If you're on the ground, your height is just 0. So the equation would be 0 equals negative 16t squared plus 144t plus 98. If you want to reduce the numbers, everything's divisible by at least, I think everything might be divisible by 4. I don't know. I'm just going to leave the numbers alone because I'm going to do this on my calculator. I'm not asking you to leave this in radical form. We're just going to use quadratic formula. So A would be negative 16, B would be 144. C for this problem is 98. I didn't have to do anything to set it equal to 0 because it's equal to 0 because we're trying to figure out when the rocket's going to come back to the ground. All right, so I'm going to do negative 144 plus or minus square root. Again, this will probably be a huge number. 144 squared minus 4 times negative 16 times 98. Don't think you're doing anything wrong. We're going to get a huge number under here. And then 2 times negative 16. And then just do me one favor before you start trying to use the calculator to take square roots or anything. Just simplify that 144 squared minus all that. So we're going to do 144 squared minus 4 times negative 16 times 98. This is a huge number here. Okay, 27,008. The bottom of that fraction is just going to be the same as last question. 2 times negative 16 is negative 32. Okay, now, remember what I told you. If you look back at this graph, if I actually solve that, one of the answers will be negative, and we don't want to pick that because we don't have negative time. We want to pick the positive answer. So, if I do, and we'll show you this real quick, if I do negative 144 plus square root 27008, hit equals, divide that by negative 32, and you can see right there I got a negative answer. We can't have a negative time. So I'm going to do the other one. Negative 144 minus the square root of that 27,008. I'm going to divide that by negative 32. And that's actually going to be my answer. We can't have a negative time. This has two solutions, but in terms of our situation, we just want the positive answer. So this is about, let's say, 9.64 seconds. On the homework, it should just tell you to round to the nearest hundredth, so just 2 decimal places. You are not cooked. If you can type numbers into a calculator, you can do this. Is anybody having a question? I will give you the formula, I promise. Okay, so today we're going to work